Okay, so I think we can get started with the webinar. Thanks a lot for joining. Uh, Today, the topic of the webinar is confidently managing third-party GitHub Actions in your CI/CD pipeline. My name is Varun Sharma, and I'm the CEO and co-founder of StepSecurity. StepSecurity was founded in October 2021 and is focused on securing CI/CD pipelines. Before StepSecurity, I was at Microsoft for 15 years, where I led initiatives to secure applications, pipelines, and cloud infrastructure as part of the Azure security team.
It's great to have you all join our webinar. My name is Ashish Gurmi, and I'm a co-founder and CTO of StepSecurity. I have 13 years of industry experience across Plaid, Uber, and Microsoft. Before we get started, a few housekeeping notes. Like Varun said, chat is enabled, so please feel free to provide your input and comments in real time. For questions, we recommend you use the Q&A tab so that we'll make sure that we answer your question at the end of the webinar. We are planning to wrap up our presentation in about 40 minutes and keep the last 20 minutes for Q&A. We have about 12 slides to cover. For setting the context, we should take about 12 to 15 minutes. And we will spend most of our webinar time on hands-on labs. So with that, let's get started. So let's start the webinar with a poll question. You should see a pop-up on your screen. We would love to know what is your most pressing security concern when it comes to GitHub Actions? Wait for a few more seconds. Cool. Let's start the webinar by analyzing a typical GitHub Actions workflow. This workflow has one job with 3 steps. So at line 53, we are checking out the source code. And then at line 56, we log into our AWS ECR account. And then finally at line 64, we build a Docker container image and we push it to the AWS ECR account. And let's see what can go wrong here. GitHub Actions is a high risk environment because first of all, GitHub Actions is a high privileged environment. It typically generates production builds, as we can see at line 64. In addition, it has access to admin cloud credentials because it manages cloud environments, as you can see at line 60. In this webinar, we are going to be focusing on 2 primary attack vectors. So the first one is the use of untrusted third-party code in this highly privileged context, as you can see at line 58 and line 65. Second, we have seen a lot of adversaries after they compromise an enterprise environment, they use GitHub Actions either to persist or elevate their access within the enterprise environment. And the 2 key risks when it comes to GitHub Action are related to the misuse of the 2 privileges I talked about earlier. So by compromising admin cloud credentials, adversaries can compromise the enterprise cloud environment. Similarly, by compromising the software build process, adversaries can tamper the production build and inject their backdoor in it. GitHub Actions was launched in 2018, and in a short time period, it has gained a significant market share. And one of the reasons behind its popularity is its rich ecosystem. GitHub Actions Marketplace has more than 20,000 actions that anyone can use. Anyone on the internet can publish, their own actions, and all GitHub Actions workflows by default can consume any of these actions. Even the sample workflow that we analyzed earlier, it's a build and deployment pipeline. And all we had to do to build this pipeline was to use three such actions in our pipeline. We didn't have to author this pipeline from scratch. While GitHub Actions comes with, while GitHub Actions they bring in convenience and they increase developer productivity, they have their own set of security risks associated with them. So the first one is it increases software supply chain risks, as we saw, because it executes untrusted third-party code in a highly privileged environment. A lot of things can go wrong here. On the other side of the spectrum, it also leads to abandonware risks. So the typical story here is that an open source maintainer publishes an action, and the action gets very popular, so it receives a lot of adoption. But then slowly over time, the maintainer loses interest in maintaining the action, and eventually it's abandoned, and it ends up with many security vulnerabilities. Enterprises, cannot make any assumptions about the reliability of such actions. With GitHub Action, there is one particular reliability concern, which is if the maintainer deletes the actions repository, then all the workflows that are consuming it will break. A lot of open source actions actually have a single maintainer, which again increases the risk of all the other scenarios that I talked about earlier. And finally, in GitHub, there is no way to enforce the use of an immutable actions release. So if you're using an action by either its branch name or release tag, the action version can easily be overwritten. Adversaries, also realize the value of going after CI/CD systems, and there has been a sharp rise in the number of CI/CD security attacks in the past few months. So let's look at one of these security attacks. Codecov is a very popular utility for measuring and tracking code coverage. As an engineering best practice, a lot of organizations have internal targets for code coverage. So anytime they run unit tests or integration tests in CI/CD, they use Codecov to measure and track progress on these objectives. So in the Codecov breach, the adversaries compromised the Codecov bash uploader script. So in their earlier design, anytime Codecov ran in CI/CD, it produced a detailed code coverage report. And this bash uploader script essentially uploaded the code coverage report to their backend. So after compromising the bash uploader script, the adversaries silently persisted in the Codecov environment for 3 months. And during this time period, anytime someone ran Codecov in their CI/CD, it also executed the attacker-controlled malicious code. And this malicious code read all the environment variables and exfiltrated it to an attacker-controlled remote endpoint. Now, as you may know, in CI/CD, environment variables also contain infrastructure secrets, such as admin cloud credentials. So by using these stolen environment variables, adversaries were then able to steal other high-value assets, such as proprietary source code and cloud resources. Thousands of customers were impacted because of this breach, including several large organizations such as Twilio, HashiCorp, and Rapid7. In fact, HashiCorp's signing key was leaked as part of this breach. So now that we have seen, what can go wrong, let's look at some of the recommended security best practices. GitHub provides a fantastic setting at the organization level to control what actions can be used in a given environment. We highly recommend you turn this on because this setting will allow you to create a robust third-party governance process. For risky third-party actions in use, you should also conduct regular source code audits. If you want to be extra cautious, you should also consider forking risky actions and maintaining your own forked copies, which will allow you to apply, missing security controls and implement your own change management process. To make sure that you're always using the same version of a given action, you should consider pinning action version to a specific commit SHA. Anytime GitHub executes a GitHub Actions workflow, it automatically generates an API token called GitHub token. And this API token is elevated by default. You should also consider using least privilege token for your GitHub Actions workflows. And finally, you should enable Dependabot or Renovate bot to automatically upgrade action versions. So once you enable the organization level setting, which allows only specific actions to be used in your environment, this is how a typical, a workflow looks like to add a new action in your organization. So the process starts when a developer tries to use an action which is not in your allowed list. So the developer receives an error message and they reach out to either security or DevOps. Then a security engineer conducts a security assessment of the action. This includes reviewing source code, running a bunch of security tools, analyzing repository settings, and so on. And based on this security assessment, they come up with a risk rating. If the risk is high, it requires further approvals, after which typically the security team forks the action, applies missing security best practices, and then eventually the developer is allowed to use the fork copy in their workflows. Another poll question. We would love to know if you have a security review process for third-party actions. If yes, do you also fork them? The process that I covered earlier, has its own fair share of challenges. So the first one is that it's time consuming because the security engineer is manually reviewing such actions. It takes a while for them to complete their security assessment. Second, these security assessments are highly subjective and there is no standardization. So two security engineers from the same team will can come up with two different results for the same action. For organizations that do not fork GitHub Actions, there is really no good outcome when it comes to risky third-party actions. So either they can allow these risky third-party actions, in which case they are accepting the risk, or they don't allow them, in which case they are hampering developer productivity. And finally, even the organizations that fork GitHub Actions have to pay ongoing maintenance cost.
Okay, so now that Ashish discussed about the concerns and issues and a typical process in detail, let's look at how StepSecurity can help address some of these issues. So we have an end-to-end GitHub Action security platform that helps address these issues at three different layers. At the bottom is the CI/CD infrastructure security, and this is the infrastructure and network security of the runners themselves, which are the build servers, which could be either GitHub hosted or self-hosted. And here we have an agent which runs on the runner, which is called hardened runner, which provides outbound network traffic control as well as runtime security. At the next layer is pipeline as code, which are your workflow files, which are the YAML files. And we analyze these to find misconfigurations, things like token permissions not being set correctly or OpenID Connect not being used. And then we go one step further to help you address those by automation using automated pull requests. And then the final layer is where you're using these third-party GitHub Actions and where we offer a way for you to get a objective score for these actions and also step security maintained actions where we actually fork and maintain these actions for our customers. So next, what we can do is to get into the hands-on lab. And what I'll do is that I'll follow all of these steps and share my screen so you can follow along. And if you want to follow along, all you need is a GitHub account. You can use your personal account and fork this repository, and you just need a browser to click through the GitHub UI to follow these labs. So you don't really need any IDE to be set up. So I'll go ahead and share my screen and we can continue with the lab. Okay, so you should be able to see my screen now, and uh, what you see here is GitHub Actions Goat, which is an educational project which is deliberately vulnerable, and it has some of the GitHub Actions best practices that have not been followed, so that you can learn from it and learn how to fix these issues. So let's go ahead and fork this repository so that we can do the labs. So I'm going to fork this in the Step Security demo organization, and you can fork it in your personal account. Once you fork the repository, you will notice that the workflows are not enabled by default. So you can go to the Actions tab and click on I understand my workflows and go ahead and enable them. And then you should see a few workflows on the left. Now, these workflows have a mix of workflows that run on GitHub hosted and self-hosted runners, but we'll be focusing on the GitHub hosted since we can run them right away. So what you can do is to get started, if you are following along, just run these workflows, and they take a few minutes to run. So we can let them run in the background, and then I can walk you through what these workflows do. So what I'm doing is I'm just running these 5 workflows which have hosted as the prefix. They run on the GitHub hosted runners. And then we'll look at what these workflows are doing, what are the issues, and so on. So we can start with the network monitoring without hardened runners. So the first workflow we look at is hosted network monitoring without hardened runner. And as I mentioned, hardened runner is the agent for uh, the build server. And if you see here, this is a typical workflow which runs on Ubuntu latest, and it has a few actions that are being used, and it does a publish of a Docker image. And if you look at this workflow and as it runs, you typically don't have visibility into the network level traffic of this workflow. So you don't really know what kind of outbound calls are being made. And so if any of these third-party actions is compromised or is malicious and is trying to steal your code or credentials, you wouldn't really have that visibility. And that is the default state of GitHub Actions or any CI/CD platform for that matter, that there is no real visibility into the outbound network traffic. So that is what this workflow shows you, that without uh, hardened runner, There is no network monitoring. Now, if you look at the one which says hosted network monitoring with hardened runner, in this workflow, you'll notice that again it runs on Ubuntu latest, which is GitHub hosted, but this time it has an action which is StepSecurity hardened runner. And this is the agent which then gets installed on this VM and it starts to monitor it. So here you'll notice that in the hardened runner step, there is a link to view insights and recommended policy. And when you click on it, you will see uh, this dashboard, which is the StepSecurity dashboard, and this dashboard is public for public repositories that are using these workflows. And so here you'll now see that it shows you network level events and file override events and HTTPS events for this particular run. And so what it's saying is that when you ran this particular step, crazy max slash gh action GitHub status, that the node process made this outbound call to githubstatus.com. And similarly, when the checkout action was run, which uses action slash checkout GitHub action, this process git remote HTTP was called, which made an outbound call to github.com. So now you actually have visibility into what these actions are doing in terms of outbound network traffic. And this is really important because going back to the slides that Ashish discussed, the number one threat here is that a compromised action or a malicious action or a compromised dependency which is in the CI/CD pipeline will typically try to exfiltrate credentials or the source code from private repositories. And so in here, in addition to these uh, DNS and network traffic, you can also look at the HTTPS events, which currently show outbound HTTPS traffic for github.com and api.github.com. And so in here, you can see that there was a GET request made to the StepSecurity demo, or which is expected, for downloading source code. But if there was a call being made to a different organization, which was a post or a put method, then that would be something to investigate. Now, in addition to this monitoring of network traffic, uh, we also show you a recommended policy to block traffic to only the allowed endpoints. And this can be done at a job level. So this is based on the aggregated endpoints from the past runs. And here, since this workflow only makes calls to specific endpoints, those are shown. In fact, if you notice here, the npm install step is actually making a call to attacker.com, and you would not have found out about it if there was no such monitoring. So now let's look at how you can set up filtering for sensitive workflows that have access to CI/CD credentials. And in this case, you'll notice that we have taken that recommended policy and set it back in the workflow file. And now if there's any traffic that is not in the allowed list, it's actually going to be blocked right then, right? So it's blocked in real time. And we did not include the attacker.com endpoint in here because that should obviously not have been there. And so now if you look at this workflow run, you will notice that in the npm install step, this connection to attacker.com was blocked. And for this, if you look at the insights, you will see that this call to attacker.com shows as blocked. So this is how you can monitor and reduce risk from third-party actions and dependencies that are compromised or malicious at the infrastructure layer, at the runners themselves. And this was about network monitoring, but the second threat, as Ashish mentioned, is about tampering of source code or artifacts during the build process. And this is what had happened in the SolarWinds breach, where a source code file was modified during the build process. And this is an example of that where, again, this npm install step is overwriting a file. And now you can see that in the file overwrite events that the index.js file was actually overwritten. And for a typical publishing workflow where you're releasing a build, such kind of overwrite events shouldn't really be happening. So when this happens, you know that something might be suspicious that should be investigated. So what we saw here, is CI/CD infrastructure security in order to detect these attacks. And what we've seen is this on hosted runners. Now, the same thing also works on self-hosted runners, which can be either a, Actions runner controller for the Kubernetes environment or self-hosted cloud VMs. And the advantage there is that you can actually install this hardened runner on your infrastructure, so you don't have to change all the workflow files to explicitly add it. To explicitly add it, you need to do that only for GitHub hosted runners, since the VMs are managed by GitHub. But if it's your own environment, for Kubernetes, you can actually install it as a daemon set. And for self-hosted VMs, you can bake it into the VM image. Um, see, there is, okay, so I think we can take this question on uh, pinning in the next part. So this was about, so one of the questions is, how do you make sure that hardened runner does not break my workflow runs? What if your backend goes down? So to answer this question, hardened runner itself is an action and it runs, uh, on the build server, and it connects to our backend API to send out this telemetry. So even if the backend is down, the only thing that would happen is that the telemetry would not get sent out for that particular duration during which the backend is down. But that still does not hamper the workflow run. So for calls that we make to uh, our backend for GitHub hosted runners, the first call is to uh, download the agent, which happens from GitHub itself. And if that call fails, or the calls, like I said, to our telemetry fails, there is a timeout. And so it simply continues and does not affect the rest of the workflow. The only downside is that during that time, the telemetry would not be collected, but it does not cause uh, any kind of downtime. So I hope that answered that question. So now let's look at the next aspect, which is around the security of actions, which third-party actions. And I think that's where I can answer the other question around pinning. So in order to look into this, we need to install our GitHub app. Uh, and if you're following along, you can click on the Actions tab, and you will see this Install App button, and you can just install it on this forked repository. So this app needs permissions to the GitHub Actions API. So it just needs read access to the GitHub Actions API. And we also tell you if your secrets have not been rotated, and for which it needs secrets read and organization secrets read. But this only gives it access to the metadata about the secrets and not to the actual secrets. So as you'll notice, this app, by design, does not need access to your source code. And all of the analysis is done just based on the workflow runs and the build log. So here I'm going to go ahead and install this app on this demo repository, and I can just select the GitHub Actions code repository and go ahead and install it. And then you should see this screen with again the link to the same dashboard. And if you click on this, it should redirect you to the dashboard now, which has more information. So if we again go to the Actions tab, here you can see all of the GitHub Actions that are in use across your organization. So let's say your organization, has 1,000 repositories and several thousand workflows that are running. This is your, single place where you can see the list of all the actions across your organization. And for each of them, you will notice that there is a score, and then you can actually sort it by the score to look at what are some of the actions that have a low score. And here, let's look at, the first one, and which has a score of 3 out of 10, and let's look at how is this calculated and what information do you see here. So here you can see a link to the GitHub repository. How many stars does that action have, the repository have, and whether is it a node action or a Docker action. And then we calculate an objective score based on these 6 attributes. Does it have a valid license? Is it maintained, which is calculated based on how many commits and issue activity does it have in the last 90 days? And this helps to understand whether this may have been abandoned. The next attribute is how popular this GitHub action is, which is calculated based on the usage by other open source projects. And if it is more popular, then it gets a higher score on the popularity. Next one is about branch protection, which checks whether branch protection has been set up, which tells us, if there is are pull requests being done to merge changes, or are they being pushed directly to the main branch, and if their reviews have been set up, or is it just a single person who is doing all the changes. The next attribute looks at vulnerabilities in the dependencies of that action. And then the final attribute looks at the security policy, whether there is a security.md file. And if not, it means that if someone finds a security issue, it might be hard to reach out to the maintainer. And so going back to the slides and the process, that typically organizations have of deciding to use an action, this really cuts down on the time that you need to evaluate a third-party action and also gives a more objective rating for it. Now, on the right side, you will notice that you also see the networking behavior of these GitHub actions, which tells you that in real scenarios, when this action was used, what kind of outbound calls did it make? And this is again done through the hardened runner GitHub action. And we calculate this based on the usage of hardened runner in public repositories. So since it's being used in over 2,000 public repositories, we take the data from there and surface it here so that you can have a better idea of the networking behavior of these actions. So you can see what public workflows have contributed to this data. So here is an example, where CISA Gov, which is the Cybersecurity and Infrastructure Security Agency, is using, this hardened runner in their repository. And so this is a public repository. And as they use it, they actually use this action, which makes this call. So that's how this data is, calculated and surfaced in here so that you can tell, what kind of outbound calls does an action make before you start using it, or if you are already using it, you become aware of it. Now, this is the scenario where you already are using certain actions, but let's say in the process, a developer asks that a new action be allowed. you can then come in and actually search for it. And so you should be able to search for any public action and see the score. So now, like Ashish mentioned, Codecov had been compromised some time back, and at that time, this would have shown outbound connections to certain IP addresses where this data was being exfiltrated. But now you can see what kind of uh, traffic does it have and what kind of score does it have, and then based on that, you can allow it. Now, as we calculated, as we uh, uh, as we calculated these scores for third-party actions, what we realized is that, even though there is an objective score, uh, a lot of times that score is low, and it tends to have similar reasons. It may have been abandoned, may not have good branch protection, there may not be any kind of security tools running on it. And so what we've done is we've gone one step further and introduced what we call as StepSecurity maintained actions. And here what we do is that on the request of our customers, we onboard third-party actions as a StepSecurity maintained action, where we fork the action which has a low score and may have been abandoned, and then maintain that with good standing in terms of applying security best practices and change management practices. So here you can see a comparison between a third-party action which has a very low score versus a step security maintained action. And in this case, you can click on the action, and these maintained actions are also public and they're also open source. But what we've done here is that before we fork it, we do a full manual code review of the code that we are going to push into our maintained repository. And then after we've done that and pushed it, we apply security best practices. So we add a dependabot file if it was missing, so that we get to know about periodic updates. We also add CodeQL and dependency review workflows so that every change goes through some automated security testing. We set up branch protection, and all changes to these actions require review from one additional person from Step Security, in addition to the person who's making the change. And so with these changes, the security score of this action increases. And this solves two big fundamental problems. The first one is that now the developers, in your organization get access to a much larger set of safe and reliable actions, where, earlier you may not have allowed the use of certain high risk actions. So there's a, higher set of actions available for use that are safe and reliable. And second, it cuts down on the time that you may be spending in forking and maintaining these third party actions, which can take a lot of time. If it's a node action, every few years, the node runtime needs to be updated, which needs changes to all of the actions. And then there may be changes in the upstream, which need to be brought in, which again requires the full review process before the changes can be merged. So that's how, maintained actions actually takes this a step further than just providing a score, uh, to really help you uh, manage the risk of these third-party actions. So let me look at a couple of these questions, right? So now the first one is pinning all actions results in too many automated dependabot pull requests that developers need to review and merge. How do you balance this with the security risk? Now here, after maintained actions, this is one of the advantages wherein, since Step Security is already doing the review of these actions and each of the changes that are being made to it, that you don't necessarily have to now pin to a commit SHA. You can just pin to a major version tag, knowing that there is already a review happening for all changes to those actions. And that's how it actually removes the need for pinning to a commit SHA for all the third-party actions. Uh, I hope that answers that question. The next one is I already have a large number of actions in use. Can you give me some practical tips on how I should use your rating system to analyze existing actions and improve overall security? So this is actually, actually a great segue into the next, uh, next demo that I was going to do or part of the hands-on. So let me cover that there. So here, if you click on the overview tab, you actually get a overview of how well you are doing with respect to GitHub Actions security across your organization. So these are a set of controls that are derived from the GitHub Actions security best practices, and they have been automated. And with this, you can actually get a view, right? So if you have a large number of actions that are already in use, the first one looks at the control is that only third-party actions with a high score should be used. So if you click on this, it will show you which of the jobs are using actions with a low score and which of the jobs are using actions with a score above uh, 5. So if it is 6 or above, then it shows it as passed. But if a job is using a action with a score of below 6, then it fails this control. So in here, for example, these workflows that we ran are using these actions which have a low score. And so now you know which of your jobs are using actions with a low score. And now in order to fix this, you can set up a process and start migrating it. So one option is that you can start migrating them and replacing them with StepSecurity maintained actions. And if it is not available, then you can request that onboarding. And once it is onboarded, you can then you know uh, communicate to the developers to use the maintained action instead. And if you find that a certain action has really low score, you can and if you still want to use um, you use that action, then the maintained action is the option. Otherwise, you can then just not allow the use of that action if if that is an option. So I hope that answers that question. So the next question is, how far will StepSecurity go into maintaining actions even if the original action is abandoned? Example, upgrading to newer versions of Node might require rewrites of parts of the code. And yes, this is the value that StepSecurity provides. So even if the action is abandoned, the dependencies continue to get updated. So we will continue to update those dependencies. And in fact, in the example I had shown of one of the action, in that case, when we updated the dependencies, because that action had not been updated for 2 years, we had to also update the code because some of the test cases had started to fail. So once we maintain an action, we take full control of the supply chain of that action and of the functionality, and continue to support that uh, as long as our customers are using that action. So I hope that answers the question. So now we can look at some additional controls, especially related to the pipeline as code security. So now here you can also see certain controls related to pipeline as code. For example, if the token permission has not been set correctly for certain jobs, then this control fails, and this information is available in the build log. So we provide a evidence to the build log where you can go and see, that this job has excessive token permissions. And this is again a risk from a third-party action or a dependency perspective, because if this token is stolen, it can then be used to push code or push packages into the repository. And similarly, you have another control related to OpenID should be used. So we can detect if a job is using one of the actions that supports OpenID Connect, which allows you to use short-term credentials, and if that is still not being used, then that control would fail. Now, in addition to just showing these pipeline as code issues, we also have capability to fix them using an automated pull request. And I can actually show you examples of uh, open source projects that have used this. And you can actually go to this URL and see this for yourself at uh, app.stepsecurity.io/secure/trending. So these are some really important projects that have used the same pull request functionality to apply these GitHub Actions security best practices. And you can take a look at one of these examples where our bot account is used to create this pull request. Now, for private repositories, this does need additional permissions, where you will have to set a personal access token because the pull request requires access to source code and to the pull request API. But everything other than fixing of these issues just needs access to the GitHub Actions API and the secrets metadata. So in this case, you can see that the automated changes actually apply fixes like adding a dependabot file or updating it, adding additional workflows in case you want to standardize workflows across your repositories, and also making fixes like setting token permissions, adding hardened runner, and pinning dependencies if that is something that you want to do. So let me see, maybe there is. So the question is, will step security support the same set of functionality, insights, controls, dashboards for internally developed and private actions? So in terms of uh, insights from hardened runner, which is the insights about what that action does, we can support that based on the runs of that action within your organization. And so those insights would then only be visible to you. And of course, the controls in terms of uh, a score, like uh, some of the aspects that we use to calculate the score requires access to that repository, right? So currently, it is only done for public repositories. For example, branch protection, whether that is set up or not, requires a higher level of permissions if it's a private repository. So we won't, as of now, be able to evaluate scoring of certain attributes if it is internally developed. And of course, if it is internally developed, we cannot also maintain it, because we do need to know what that action is. But this is an interesting question, and maybe we can follow up on it offline. So with that, uh, that was what I had for the lab and the demo, and we can go back to the slide deck. So this is just a summary of what we discussed, about the GitHub Action score and how is it calculated, and that you get runtime analysis of what that action does. And the next slide is a summary of the maintained actions, which is the actions that are forked and maintained by Step Security. And we apply stringent security best practices and change management best practices for these actions so that you don't have to do this. And that brings us to the end of the webinar. And feel free to post any additional questions that you may have, and we can answer those. Okay, so looks like we don't have any additional questions. So I think we can go ahead and close the webinar. Thanks a lot for joining and for asking all these uh, great questions.
Thank you, everyone.